Yeah, good morning, ladies and gentlemen. I'm acutely aware when you give a presentation like the one I'm about to do, of trying to make it relevant. This is the first time I've ever presented data from a New Zealand research project in Australia. I've usually been presenting Australian data. So I hope, particularly bearing in mind that we're in a drought scenario in this part of the world, that it won't be seen as the smug POM coming over and saying we can do these kind of yields. Because I actually feel that growers in high yielding and low yielding scenarios can learn a lot off of one another. I thought I'd start by actually introducing you to Mike Solari. Now Mike is the world record holder for wheat. And his world record, and here he is with his crop of Einstein in the south of South Island, did 15.63 tonnes a hectare. I was brought down to size at a very early stage in the northern region by being told at Spring Ridge, well, actually that's nothing because we can do 7.5 tonne of wheat and 7.5 tonne of sorghum in the same year, so we can do 15 tonne. But what I'd like to do is to focus a little bit on whether we can push beyond that target and at the same time try and relate it to the project that Alan Peake leads, that I'm involved with Alan on, in the irrigated northern grains region. And I thought perhaps just to start with, what we might do, I'm extremely fortunate. I get the chance to look at different trials in different parts of the world. How do these crops compare between Australia, New Zealand, irrigated dryland? And so I put together a bit of data where we've been looking at trials in a bit of detail with their harvest dry matters and their grain yields. And I've chosen some different sites from some water use efficiency work that we were doing further south in New South Wales and northern Victoria. And what you can easily see is that increasing yield comes from increasing biomass. And you heard this a number of times yesterday. But it also comes from increasing the amount of that biomass we harvest as grain. And you can see this with regards to these figures here. 49% or 50% is the proportion of a crop canopy that was about 26 tonnes dry matter at harvest. We were harvesting from that about 50%. And that was giving us a grain yield of about 15 tonne. And you say, well, hang on a minute, 15 tonne isn't 50% of 26.5, but the grain yields are done on the basis of 12.5% moisture, and the harvest index are done on the basis of a dry matter comparison of grain and biomass. So in each of our environments, whether we're a grower here in Emerald in the Queensland Central Highlands irrigating, or whether we're on the Canterbury Plains at Ashburton or Careen at that lower level, we have agronomic levers that we can pull that are within our control. They could be nitrogen timing, they could be sowing, they could be plant population. There's a whole bunch of levers that we can pull to adjust how much biomass we've got per unit area. If you take one of those levers, just to give you a little example. This is from the Careen site in 2010, and it seems rather topical at the moment with some of the sessions that I've been to. Row spacing. What happens when I have a row spacing trial of 9, 12 and 15 inches in wheat? Loads of them going on. And an excellent review that's just come out that Peter Martin's been involved in, looking at the basis for all those results and what they tell us. Luckily, this one's in line with a lot of the conclusions from that report. And what you can see is that as we actually decrease our row spacing, so we increase our total harvest dry matter. Significantly so by the time we get to 9 inches. You can see that that's been associated with an increase in yield. And you're saying, well, is this irrigated wheat? Well, practically everywhere down the eastern states in 2010 was irrigated. So it's high rainfall. But it's, within that respect, a dryland crop. It's not irrigated. That's just one example of a lever that's been pulled, increased our biomass, and it's increased our yield. But what actually makes up having more biomass here? What does the crop look like? Well, this is just looking at the crop structure. And it's saying, okay, these are all planted at the same seeding rate per unit area, but with narrower row spacings, and it's not always clear why, we always establish more plants per unit area than we do with wider row spacing. So plants here in blue, establishing less on wider rows. More plants per unit area led to more tillers, and although there's a slight drop here through tiller death and mortality, we produce more heads per square metre on 9-inch row spacing than we do on 15. And so the biomass then was manifest as a head number. And in fact, when I first had the chance to speak in Australia around canopy management, I came up against the adage that if you wish to increase yields of wheat, you effectively need 100 more heads to give you 1 more ton of grain. Do you know what? I think that that adage works really well between about 2 and 5 ton. That you can actually see a number of experiments where head number and biomass relate clearly to an increase in yield. So going back to some of those Canterbury Plains yields at 15 tonne a hectare, that adage then prompts the question, how many heads do I need for 15 tonne a hectare? It's easy, isn't it? It's 100 more heads for every ton. 1,500 ears per square metre. So let's go to the Canterbury Plains, have a look at a trial that's based on one of our trial sites there and say, let's ask that very question. Here's the yields of 7 varieties. Now, in fairness, a lot of those names won't mean very much to you, but you may have heard of Clare before. It's extremely popular in Northwest Europe in the early 2000s and has been grown, although it's too long season, in places like Tasmania and southern Victoria. These yielded, here you can see, around that 14.5 to 15.5 to 16 tonne. How many heads did they have? Pretty much right down the middle here at about 550. So 550 heads producing 3 grams a head gives you 15 tonnes. So that old adage, when you think of increasing yields, the adage of it's all about head number probably works neatly between 2 and 5 tonne, and then that relationship starts to break down and you're much more dependent on something else. But what's possible? Is it possible to push beyond that world record? And at the moment we've got growers that are actually have got the phone numbers in their header cabs to ring us, or rather ring my colleagues, because I'm never there, I'm in Australia. Ring us if that yield monitor hits 22 tonnes. Why 22 tonnes? Because if it hits 20, we know that it's probably 10% out of whack, and we only get excited if it gets to 22, and we might be somewhere close. The first time we went out to one of these phone calls to monitor, and all we're interested in is describing what that huge crop might look like. The first time we went out when somebody's yield monitor hit 20, it was 14 tonne a hectare. But what's possible? Well, within this project, we're working with Plant and Food Research in New Zealand, and they basically, by using the wheat calculator, which is a model that's closely related in several of its modules to what's in APSM, what this showed us was that if we could increase our radiation capture by sowing earlier, we would in effect increase our grain yield. And of course we get very excited when we see things like 19 tonne a hectare, because it's never been achieved. But it's a crop model. It's never been validated for those parameters of sowing any earlier than April. So that's one of the things that led us to establish this project. We've only got 6 years to do it. I don't know whether we'll do it, but it's the journey that's important. And that is that we've set the task of trying to grow and describe a 20 tonne a hectare wheat crop by 2020. One of the key aspects of the project is to see if we can increase our period of light interception. That could be by growing the crop over a longer season, and we've got the possibilities of doing that with an irrigated crop. It could be through better looking after the tail end of grain fill in terms of our green leaf. In New Zealand, and I've seen it on the Liverpool plains, we can sometimes lose our flag leaves in grain fill through something that I would describe as pollen scorch, where detritus associated with the pollen sets up disease actually in those flag leaves, and we lose them prematurely. So this is a big focus. We're interested in talking to anyone around the world who can provide us the germplasm that might be adapted for a longer season. We're scouring Europe for anybody who can give us an F1 hybrid, because if we can get F1 hybrid heterosis on a 16, 17 tonne crop of say 10 or 15%, we'd be getting very close. Okay, thanks. We're trying principally though to match our agronomy to a longer growing season. And you know, that's where there's a lot of common linkages with the project that Alan is leading. And I don't know if you can see that particularly well in here, unfortunately, but that's what happens if you grow wheat in our environment in February. It's got the same roadblocks as our Northern Irrigated Grains project. Goes flat. Only problem is, that's going flat in June. We planted in February, it's got 3 tonne of dry matter and it's gone flat. So we have to be able to control this kind of lodging to intercept more light. It's increased our disease pressure enormously. So what we need is cultivars that can stand, don't get masses of disease when we plant them early, and is adapted to a longer growing environment. PGRs, we've learned a huge amount about PGRs in this last year with these high yielding crops. Principally, the fact that some of our timings for PGRs have had to move to the autumn where we've planted so early. Our traditional spring timing of growth stage 32 for a PGR mix that we commonly use is inferior to the same rate of agrochemical applied in the autumn. So looking at this data and also looking at the power of sequencing, autumn and spring, we've come a long way forward. So if we can control lodging, which is just the same as that Northern Irrigated Grains project, then what are the potential rewards that we can reap through intercepting more light and sowing earlier? Okay. 7 cultivars, 4 management strategies. Let's not worry about these cultivars other than there were some key differences once you started pushing these for yield. These are our 4 management levels. 140 kilos of N or 240 kilos of N. Think about that one. 240, 140, and I'm trying to produce 30 tonne of dry matter. We'll come back to it. SDHI and STR are strobilurin SDHI fungicide programs designed to keep our crop canopy as clean as we can possibly keep it. Our yields gave us great excitement. We had never seen yields like these. Those are the levels of management, and these are the varieties. And you can see these two seemed particularly well suited, but this was where we were increasing our yield at this high level of nitrogen 240 plus the strobilurin and SDHI fungicides. There's not time to go into every aspect of that matrix. There's some great things in there. But what I want to show you is how does a 17-tonne crop yield? Where does the yield come from? And what this shows you is grain yield versus grain number. Look at the correlation of these different cultivars. They're all either sitting parallel to this line or on this line. Higher yields come from more grains per unit area. They are related most to the number of grains per head. So there's the grain number, there's the grain number per head. They are not related to the size of the grain. And here you can see that the highest 1,000 grain weights were in effect the lowest yielding. The biggest grains in a cultivar produced our lowest yields. Any similarities? Queensland Irrigated Grains project? I think I can just about put a line through that might look like a correlation, but I definitely can't with that. So that's the influence of grain size on an irrigated crop at Emerald. That's grain number. So, finishing off, Mr. Chairman, all I want to show you is that when you start looking at the makeup of some of these crops, as we increased our levels of management, the one thing that we've learnt is that possibly to do 20 tonne, we have to abandon some of our old adages around ear number in New Zealand. We don't think we're going to exceed the world record by sticking at 400 to 550. We think we may have to lift to 600 or 650 using early sowing, which produces stronger tillers. So, in conclusion, grains per ear correlate strongly to yield, not the size of grain or so much the ear number, although just as I've said, we think we might have to lift our ear number a little. Grain numbers per head or per unit area is the overriding factor. Crop lodging, same roadblocks as you face in your irrigated grains project, and we have to get over that hurdle. That's going to require us much more focus, particularly around matching our N to our N supply. And lastly, we're looking for cultivars that can give us those three factors: lodging resistance, disease resistance, and adapted phenology. And we think that might mean not picking cultivars that have particularly large grains, but less ability to put grains per head together. Many thanks, Mr. Chairman.
Thank you, Nick.